Here we have a variable called direction of type string. Now the type string can accept any JavaScript string, for example a dictionary spelling of the word north. However, because it accepts all strings, you can even provide it with a string that is a bit poorly spelled. Now if you want to ensure that north is always spelled with the correct spelling in your codebase, there are a few JavaScript runtime solutions to that problem. For example, you can create a variable pointing to this string north and only use that variable instead of typing this string inconsistently in your codebase. Now in addition to all the JavaScript runtime solutions, TypeScript also provides a compile time solution to this problem in the form of literal types. TypeScript allows you to use any string literal in a type position, for example, the literal string north. And now the only value that can ever be assigned to this variable is the literal string north. Any other type or string will result in a compile time error as shown over here. Now of course a variable that only accepts just one string literal is not particularly useful. And you would most commonly use a literal type in a union. For example, we can create a union of all of the cardinal directions that can be used for this direction variable. And now anything that is in this union will be fine and anything else will result in a compile time error. Now one great thing about literal string types in TypeScript is that they also show up in autocomplete, which can result in a great developer experience. Now just like any other union type in TypeScript, we can extract this union of string literals into a named type alias, for example called cardinal direction, and once you have this type alias, you can start using it in a library of utility functions specific to your domain. Now in addition to literal strings, TypeScript also supports literal types for the boolean true and false as well as any number value. To demonstrate that, let's look at another example. Now we can represent the value of a traditional dice as the number values 1, 2, 3, 4, 5, 6. And then we can create a utility function that uses math.random to roll a dice. We use the return value from math.random and scale it from 0 to 5.99999, you get the idea, and then use math.floor to limit this value to be 0 to 5, and then scale it by adding 1 to be 1 to 6, which matches our dice value type, and we inform TypeScript of this fact by using a type assertion. Now once we have this type and this utility function in place, we can start using it in our codebase, and at any point if we try to use it improperly, for example try to compare the result of a roll dice to the number literal 7, which is not a member of the dice value, we get a compile time error from TypeScript, keeping us from shipping bugs to production.